Thanks everyone for joining us. I see we have people from Italy, we have people from London, we have people from Hong Kong. I'm Ninos. I'm joined by Omar. We're both from Arrington Capital, and very soon we'll be joined by Silvio, who I know everyone is here to see. I mean, it's pretty amazing to see that over 500 people have registered for this in less than a day. The reason we're putting this webinar together is we very recently published a research thesis on Algorand, which was actually a follow-on from a paper that we wrote in June of 2019. It's a 40-page document. I encourage everyone to read it. But we wanted to sort of put this webinar together just to run through the high level. The way that we'll be structuring this is we'll very quickly sort of run through the high-level arguments for the first few minutes, and then we'll have sort of an open dialogue with Silvio very shortly after that. All right, so let's kick in. Now, I guess at the core of our thesis is this idea that today's market is now underweighting decentralization. And when we think about decentralization, it's really one of the oldest and sort of most core ideals in all of crypto. And what that means in practice is, how can we scale layer one blockchains without giving up decentralization? Now, if we think about it, sort of the discussion and the dialogue for years was exactly that. How can we do this without giving anything up? And it was, in a sense, a very utopian and sort of high ideal of crypto, in particular Ethereum. With our view is with the rise of centralized DeFi and with the rise of DeFi itself, we've seen this sort of explosion of centralized and semi-centralized L1s, which have not only attracted users and sort of seen this explosion in liquidity, they've also fundamentally sort of forced the hands of the layer one idealists who, in our view, are today potentially over-indexing on L2 as a panacea solution for Ethereum scaling. And we think about this whole dynamic and the wars that are going back and forth between these various ecosystems as this idea of blockchain pragmatism, right? As long as we can hunt for yield, as long as we can search for yield, it doesn't matter what we give up. It doesn't matter what sort of technical trade-offs we accept. And in our view, and based on our research, we think this is potentially a dangerous trend, and it really does break with sort of the old guard of crypto, and it could seed long-term tail risk. So I guess we're arguing that the market is underweighting decentralization, but the question is, what is decentralization at its core? When we think about any layer one blockchain, we divide it into sort of two classes, right? Users and securers. And the way that we define a decentralized blockchain is a blockchain where there's maximum overlap between users and securers. So for example, if one user is a securer, that is a perfectly centralized blockchain, right? If all users are securers, that is a perfectly decentralized blockchain. And we can see this idea, and we can sort of analogize this from a political perspective. So if you take a king, right? A king is a single node, a single validator, who secures the entire network. Now, as his economy grows, as his economy prospers, he becomes an increasingly smaller percentage of the network. So that single securer becomes a smaller piece of the overall pie, which in the long run creates centralization. Now, what we have on the right is the famous picture of the founding fathers of America ratifying the Declaration of Independence, which gave birth to this idea of self-government. How can you eliminate the divide between citizens and governments, right? Between users and securers, where in fact, the network becomes more decentralized as it grows. Again, the challenge with centralized systems and centralized blockchains is that over time they become more centralized, right? They have a lower decentralization ratio. So for example, if we take a layer one protocol, the fastest, fanciest layer one technology of 2021, that say has 500 validators. Well, as the network grows in size, 500 validators sounds great, right? Sounds like a pretty sort of distributed group of people and entities. However, as the economy grows and as the system takes off, that group of 500 people become an increasingly smaller percentage of the overall network. Now, the reason why we're pretty sort of fascinated with Algorand, and the reason why we sort of decided to publish this research paper, is we believe that Algorand is the first layer one to fundamentally break this paradigm. It's the first L1, in our opinion, where the users and securers of the network can scale together. So the network could theoretically grow to trillions of dollars of value, and yet that overlap between users and securers can remain relatively high. In fact, the network could theoretically become more decentralized as it grows.
So now that we sort of know what decentralization is, the question is, why is it important to be in a decentralized system? Well, as a user, it turns out, from a practical perspective, you always want to be in a system that tries to become decentralized over time. And the reason for that is quite simple. As a centralized network grows and it stores and secures more economic value, the bounty or the profitability of trying to attack a network with an ever decreasing amount of people securing it always increases in time. And so it's really sort of an accident waiting to happen, right? You know, the system gets large enough and ultimately the bounty on it becomes so large that someone tries to attack it. Whereas a decentralized system is sort of the opposite. It gets harder and less profitable to try and attack as it grows. If we look at the market today and how it tries to approach decentralization, a very popular method is this idea of bonded proof of stake. And all that means is that in order to secure the network, you have to put up as a bond on the table something that says, I'm willing to behave, and if I misbehave, you can slash some of this stake. Now, there are a few problems with that. The first being, how do I decide what is the correct amount of stake that's going to make sure that I behave? I mean, if I put up $100 and I'm using that to secure $50 worth of value, that seems reasonable, right? But if all of a sudden the network grows and it starts to hold tens of thousands of dollars, my initial stake is small relative to this value, right? The other problem is there's an opportunity cost, right? If I'm a user and a securer of the network, I want to be able to use my money to do things on the network and not just put it as a bond where I can't touch it. And so naively, one would say, well, you're generally rewarded for this by some sort of staking reward, right? You're going to put up your bond, and depending on how much you have, you're going to be rewarded for it. The problem with that is the rich get richer in this type of system, right? If I have a large stake initially, it continues to grow in proportion to my original stake. So this ultimately leads back to a centralized system. So we think that this is really an incentive problem. So how does Algorand continue to remain decentralized even as it scales? Well, it does through this idea of a cryptographic lottery. And all that means is that every user on their PC at home can sort of play in this cryptographic lottery. They just pull a lever, and then depending on how many algos they have or how many tokens they have, they get to participate in these different committees. And each of these committees says something about consensus. So you see, this is exactly how Algorand makes sure that over time, the users and the securers of the network are the same. Now that we know what decentralization is and why it's important, the question is, why does it really matter? Fundamentally, the answer is tail risk. Decentralization is a very peculiar feature in that it's a feature that you hope to never use. It almost acts like insurance. And as we know, the problem with insurance is we typically tend to ignore it until we really need it. Now, the question is, who truly cares about tail risk? Institutions, it turns out, care a lot about tail risk. And the reason for that is quite simple. Even if you have a very low probability of failure, if there is enough money or enough stake on the network, like trillions of dollars worth, even a small risk of failure means that there's a lot of money to be lost. But why isn't there the same problem in crypto today? Well, we argue that there's just not enough money on crypto so that there is a risk of catastrophic loss. But when we look at TradFi and institutions, they have to have a system that hedges out these tail risks.
Cool. I guess one of the core metaphors and ideas we have in the report is, if you think about what happened after the birth of the American Republic, right? We had a lot of amazing things. So humanity adopts this new base layer, and what do we see from that? We see an industrial age, we see a scientific age, sort of a boom in technology and innovation. And the question is, well, if Algorand is able to transcend the paradigms that we see today, well, what could result from that? And we think there's sort of two core ideas. One of them being the opportunity to rebuild DeFi without this tendency towards centralization. And you're sort of able to transcend the choice between, okay, slow DeFi that's decentralized or fast DeFi that's centralized, whether L1 or L2. And then finally, this is obviously a very topical and much larger topic. But for a few reasons, we also think that Algorand DeFi would be significantly less burdened by MEV. And then finally, in a way, we kind of view this last slide as like the final boss of crypto. It's the merger of TradFi and DeFi. So in 2017, people said, blockchains are not useful for anything. In 2018, 2019, 2020, we say, okay, they're actually useful, but the problem is they're being used inside of a very self-referential system. It's the same capital chasing the same yield. So the question is, how can DeFi begin to leverage a much wider pool of collateral in the form of real-world assets, and vice versa? How can TradFi, use crypto-native systems to stimulate real economic activity? And that's pretty much a wrap for the presentation of the thesis. We can move on to the fun stuff now.
Hi everybody.
Here he is.
Nina Sommer, first of all, congratulations on the report. I really liked it. I think it is a great analysis of blockchains, but rather than the traditional analysis who looks like money movements or things like this, you go at the core of a business, which is decentralization. I happen to agree, but you may certainly make a good case about the underweighting of decentralization and how astonishing it is in an industry that it should be all about decentralization. So congratulations is a very well constructed argument and a very crucial one too.
Well, thank you very much. I mean, I was saying to Omar, we wouldn't have something to write about if it weren't for building Algorand. So thank you for building Algorand. So Silvio, we had a bunch of themes that we wanted to, pick your brain on. We sort of want to start on decentralization. And, in the report, we say, look, a system that's decentralized is one where there's perfect overlap between, users and securers. How do you think about decentralization, and how does Algorand achieve it?
Well, first of all, I think exactly as you do, but you said it better than I did, because I really like the diagram that shows when decentralization is actually achieved. So it's really when the securer and the users of the system somehow largely coincide, or to a large extent coincide. That's what is decentralization. And so Algorand achieves essentially making not only possible, but actually very cheap to participate. Because when the cost of participation goes up and you say, well, I'd love to be a citizen, but if it's so costly to participate, well, I'd like to be the subject of an empire instead, right? So that is really the trick where math and technology has to be, in order to be making participation really possible, has to be decreasing the cost and increasing the efficiency of the system.
Right. Awesome. Yeah, I mean, that's where I guess we came to this idea of sort of self-government. So for Algorand consensus to be maximally representative, it needs as many people running as participation nodes as possible. So today, as you just said, anyone can do this. I think it takes less than a microsecond to pull the lottery of sortition. You can do this from any PC. There are no hardware requirements. How do you see Algorand's sort of culture of node running picking up over time, since it's so easy to do?
Well, I think that it actually will increase, but we need people like you who actually pointed out, because it's not enough to to have under the hood something that everybody can use. So you must realize what you have under the hood is actually really for consumption. Remember, there has been a lot of inertia, and you make a very strong case that traditionally all these blockchains are becoming so centralized that people almost assume they like perhaps some aspects of Algorand, they like our layer one smart contracts, they like how easy it is to create an ASA, a new asset on Algorand. They like all this, but they don't realize perhaps how simple it is to become a validator and to be really securing the system, and then everybody's doing it. But as you pointed out, I believe and hope that this will further encourage people to actually participate as validators.
So, Silvio, speaking of participation, how does Algorand approach economic incentives different than any other networks? And what are the costs of trying to subvert consensus in light of these different incentives?
Well, paraphrasing Warren Buffett, right, is maybe the king of investors, and in the good sense. And so one time, it struck me something that he said, which is something like, sometimes inaction is the smart action. So sometimes, in designing incentives is very hard. Already designing algorithms is hard because they are run by designing protocols, which are algorithms run by multiple parties, even harder. When you design incentives, essentially you design the behavior of human beings. Human beings are very complex. And so very often you starting with a simple analysis, say, I want to incentivize this behavior, I just pay for it. And it turns out that people start maximizing their money, forgetting what you want them to do, and they try to exploit the system in another way. So there is a distinct feature of Algorand that we do not have incentives for consensus. So if you participate in consensus, you're not. So you are on the same boat. That is the idea. And therefore, and why can we do it? Because the cost of participation is so little. So let me ask to you, in fact, your audience as well. How many times have you switched off Gmail to save electricity on your PC? And the answer I expect is never, because the cost is so low. I think that you run it on the background no matter what you're using your PC for. So when you achieve this part, I don't believe it is necessary to have incentives for participating to consensus. And actually, it is a good feature because otherwise you may actually introduce all kinds of line of attack. Well, instead, the second part of your questions, I recall it to be, and so how do we make it hard to subvert Algorand? Because you really have to have a majority of the token to acquire to really be able to subvert it. And so that is a very different story, right? It's not a question of having, a majority of supercomputers who participate, say, to proof of work, because this could be very small, as you said, relative to the trillions of assets secured by things. So you must have really a handle on the majority of the network in order to subvert the network. I think that is a much better idea of security, if you ask me.
Fascinating. So can you tell us how that feeds into this idea of pure proof of stake, which is sort of different than, for example, Ethereum's proof of stake and some of the other blockchains?
Yeah, so when you said that you discussed already bonded proof of stake, which is essentially very strange. You put, most of the money, you cannot afford to put most of the money locked in a cage in order to secure the network, because the economy thrives on having money put at good use. So that is bonded proof of stake. And delegated proof of stake, well, what does it mean? That you say, you take these 11 people somewhere, say, and you say, you know what, let's put them in charge to make decisions on behalf of all of us. That is centralized from the get-go. So pure proof of stake is different. So a pure proof of stake somehow cryptographically selects, say, 1,000 tokens from wherever they are. By the way, from escrow tokens, now these tokens are everywhere. They are in your wallet, ready to be spent. They are invested in the various opportunities that blockchain offer you. They are wherever they happen to be, So they can still participate to this, a cryptographic lottery, which, as you said, is very, very, very fast. And if selected, you can express your opinion and your vote counts. And that is somehow the difference. These are not the majority of tokens in a chosen few bunch of tokens or in constrained and locked tokens. These are tokens everywhere in circulation. And that is really the approach of Algorand.
So now I guess the natural question is, you have this pure proof of stake and a system without incentives for consensus. But somehow it is extraordinarily difficult to try and subvert that consensus. You talk about this idea of it would take the age of the universe, and somehow it's sort of secured by randomness. Can you tell us something about that?
Yes, because essentially, how does a block, oversimplifying things, how does a block somehow is generated in Algorand? So by this cryptographic sortition in a microsecond of computation, so to speak, 1,000 tokens are selected from wherever they happen to be, right? And they are part of a committee who is responsible, also simplifying things a little bit, for generating the next block, okay? So, and why is this important? Because assume that you have a different system in which, to generate one block, you select one token and then the owner tells you what the block is. What's the problem with that? Well, in any system, and I would be, no blockchain is excluded from this statement, as a percentage of bad actors. But the percentage of bad actors is always small, say 1%, 2%, 10%, right? So if you have a system, assume that 10% of the money is in bad hands. Then if you choose a random token, you say you are in charge of this block exclusively now, 10% of the time is a bad actor, it belongs to a bad actor. And what is the problem? But he can tell you the token is X, he can tell me the token is Y, he can tell her the token is Z, thereby putting us in disagreement. That's a terrible thing. What's the difference instead when 1,000 tokens are selected? Because if there is, in this example, 90% majority of money, 90% of the money is in honest hands, the probability that you are going to get a committee of 1,000 tokens selected at random to be having a majority of bad money, that's very, very small. So I was thinking about it, how small should it be? So I figured out to say, well, if you produce a block a second, which is a pretty good clip, and you say, how many seconds there are in the universe? It turns out actually 10 to the power 18, right? So if you have a probability 10 to the minus 18, once in one block in the age of the universe, you have to wait the age of the universe to see one block which has a bad committee. And that is the idea. So, of course, when you have a probability, we all live in a probabilistic world, right? The way everybody can be a disastrous earthquake right now, there is always a probability. But when you think about probability like the age of the universe, perhaps we should not care.
It's good enough. It's good enough, you would say. Yeah. So this very powerful cryptographic sortition method guarantees essentially that we can continue to be decentralized even as the network grows. So to whom does this really matter? And when does decentralization count, as opposed to can we get away with having a system that's somewhat centralized?
Tell you the truth, decentralization at a system level counts when you are under attack. Okay, and so therefore it's like insurance. And right. So when you wish to have it, when you need it, and so that is somehow to have a constant decentralization. If you can technically afford it, and we put a lot of effort in Algorand to make sure that you are continuously decentralized at no cost to you, but allows us to be really secure whenever the attack comes, right? But there is another source where decentralization matters, and then is when you feel underrepresented, or you feel that you may not be taken in consideration, when you feel that the decision makers are always others but you, then to trust essentially the system in which, the economy, the very economy in which you participate, it is a good idea decentralization, because of it at the individual, at the system level, it counts when it's attacked. At the individual level, it is the source of the trust that makes you happy to live and prosper in that economy.
Wow, that's fascinating. So maybe we move on to something slightly different, which is sort of how does Algorand plan on moving forward with scalability, improving on what's already there? Algorand plans to sort of improve scalability from about 1,000 transactions per second today to about 46,000 transactions per second at the layer 1, using this idea of block pipeline. What exactly is that, and does that introduce new attack vectors for Algorand?
Well, let me give you a 30,000 feet view of our work. So think about it that there is a block proposal, right, followed by an agreement on the block, right? And so what happens is that you may have in this simplistic view of the world, block proposal, work towards agreement, next block proposal, work towards agreement. Once you see what the block is, so to speak, you can start and working towards agreeing on it. You can optimistically start agreeing on the next block while the agreement on the first continues. What is the downside? That somehow, assuming that the agreement is not reached, and rightfully so, because the block needed not to be minted for whatever reason. So then you can at the most you can start from scratch, and you have to throw out, say, 2-3 blocks and start again. So in other words, the important thing is to elevate, say, the number of transactions per second to making very high. But what happens to an attack? If it can slow you down, provided again that you have, it can slow you down, but it cannot subvert the system. And so because any attack has a cost, if I had to ask my daddy, give me some money so that I can slow down the system, will I get the money? I'm not sure. It's a bad investment. If instead the attack, if successful, can give you a multiplier 10x or whatever you spend, you'll find always people attacking. So a system in which the attack can at most slow you down, but not being of benefit directly to you, is perhaps a good reason to try to endeavor towards improving throughput without jeopardizing network security. And the risk is that you could have gone 5 times faster. You go back where you are, and that is the maximum adversary can do. Any good attack has to be financed. Perhaps you don't get finance for slow you down a system a little bit. That's the idea. So
the system is Algorand sort of dynamic in its performance and in its security guarantees.
Yes.
Cool. I mean, I think that's a pretty big deal. So we're pretty excited about sort of monitoring that over time. Silvio, we want to take a bit of a different track and sort of ask some more, I guess, philosophical questions. We sort of came to this metaphor, Algorand's the philosopher's chain. It's the most sort of ground up, first principles, L1, right, at its core. So when Bitcoin launched in 2008, the time was ripe, and we sort of see the ethos enshrined in the Genesis block. When do you think the time is ripe for Algorand, or will be ripe for Algorand? And if you were to inscribe a message into the Genesis block, what would that message be?
All right. So first of all, I'll tell you the truth. The time was ripe for Algorand when we launched, because we wanted to launch to demonstrate that consensus could be decentralized, secure, and scalable all at the same time. And so that was what we wanted to show. And so, and we started to be decentralized. In that sense, we were ripe right away, because versus some other project, let's leave them a name, in which you say, we start centralized, but do not worry, we will decentralize, or we will change the protocol and decentralize later. So that does not happen. So we did not launch until everything we had from day one a decentralized protocol. And that's where it was right. But I believe in some sense, the time for Algorand is going to be riper and riper. And the reason is because as you in your report make a point and say, hey, a truly decentralized and secure blockchain ought to secure trillions of dollars in assets. And when these people are not just putting their assets under the mattress, but they want to transact, then you are going to see which system has a smart protocol that really works, which system is really decentralized so that I can trust even in the future larger assets, as you make very clearly the case that, even a small probability of the system failure is a tremendous amount of loss anyway, even accounting for the low probability of failure. So I believe that, when the value secured in blockchain and the people really increases and the people want to more and more really transact rather than I post an asset and I do nothing with it, okay? Or I just do speculation, then I think that, we can separate the wheat from the chaff, and so somehow the blockchain really have this ability to actually let you transact securely in a decentralized fashion will pick up. So in that sense, we will, I believe an open will shine more as soon as this convergence, as you correctly say, TradFi and DeFi will happen.
Yeah. I mean, I guess it's like Algorand's core killer feature will come to the forefront as like crypto becomes more of a real world asset class and is involved in real world economic activity beyond just speculation, which there's nothing wrong with. I mean, we speculate all the time. So one question we had is this idea of like Algorand's evolvability. So you've said many times the world is constantly changing, and so our systems need to adapt. How does Algorand achieve that, but also guarantee immutability and sort of continuity of the system?
Right. So first of all, let me reaffirm. I really believe that static is death. I mean, only death is static. Life is about adaptability, and the world changes, and we must react to it. So when people look at the famous mantra, law is code, the code is law, what does it mean? The protocol will never change, right? And that is what is good about it. I'm saying, no. The ledger, once is verified, should never change, but the protocol should improve. So because no project, human project that I know of, lives long or is relevant for a long time if it cannot improve. So what we insisted in Algorand is the ability to have a consensual evolution so that we can change the protocol and consensus. And in fact, as I said before, we started by being decentralized, scalable, and secure at a consensus level. We introduced by a network upgrade voted by the 90% of the community. Say, I'm ready to have an upgrade when 90% of the people showing of the stake as through the block signifies we are ready to accept this other change. We introduce layer 1 smart contracts. Then we introduce the next improvement and so forth. We already had 3 or 4 major updates. I believe that this consensual upgradability is really the way to keep the community vibrant, because we want to solve the problems of the community, not only the ones of today, but the ones of tomorrow. The problem and the desiderata of the community change. We must be ready to have a protocol that satisfies those needs.
Interesting. So you end up with sort of a living protocol, which, funnily enough, feeds into the next question, which is we draw this analogy in the report between Algorand and the American Republic. Maybe because I'm just an Australian in America who's at the moment I'm in America and who's just loving it here. How is designing a new blockchain similar or different to designing a new system of government?
Well, in some sense it is. Some part is algorithmic, and some part is not. Is an algorithmic system of government. So that allows people to express their preferences, and I think that's what it is. The analogy is perfect, and because everybody has the right to participate. Actually, in Algorand is a little bit easier, and I'm saying because sometimes to get up, leave the house, to go and stand in line to vote, it does. If it rains, if the line is long, it takes a little bit more time. But the idea is the same, to allow a big participation. But one fundamental idea is also the same, that is upgradability. Because not to say once we have a constitution, we are done. Because the constitution was, the American constitution was put forward by very enlightened men, but over 2 centuries ago. And things change, and in fact, there are mechanisms within the constitution, with a proper majority or super majority of vote, to change the constitution. And we have changed. And this has enabled the American experiment to continue to be relevant and vibrant today. Without this upgradability, so to speak, then perhaps it would have not been so successful and so longevous. And so I think that, Omar, I think that you asked a little while ago another question which I bypassed because I was thinking, how do I answer that? And it says, what do you put in the Genesis block? I'll put start high and keep on improving.
Absolutely. Well, I think what we've always loved about Algorand is it sort of starts at first principles and forces people to, accept only the highest standards, right? And in a way, it's very much like sort of the American ideal, which is very idealistic in that respect as well. Now, I guess the last question, we've spoken about the science of cryptography, but when we were researching Algorand, it almost felt like each piece of the protocol was carefully crafted to fit the next one, right? In the same way that a piece of art is the culmination of 10,000 ideas that somehow come together in the end. What's the art of cryptography, and is there sort of an analog between an artist and a cryptographer?
Well, I hope there is, but I would say a little bit even more. I would say there is an analogy between any creativity, wherever it is, in science, in cryptography, in art, wherever, is really at the core is the strive to solve an emotional knot that you want to solve, an emotional knot. And so therefore you'll never tire because you want to solve that emotional core and resolve it, and you never tire try to do it. But this also gives you this unity of inspiration, because the unity comes from the fundamental emotional intuition that is at the core. So everything you do, even though it's in very strange domains, refers to this very unique core, and therefore it's no surprise when things fit together. And so if you look at the evolution of cryptography, in particular, the Algorand protocol being another example, but say, we started with encryption, then signatures, and then things that say, hey, gee, but there is, and then pseudo-random number generations, right? And then at the end, it says, oh, these are different things, but if you look at them, the core is this. And my emotional core, Ninos, if you ask me, is to have here safe interaction in order to have more interaction. That's what attracted me to cryptography, because not to be safe and entrench myself in something, in a house in which I don't live and interact with the world. No, I really want to be being safe. I want to explore more, put, wear my heart on my sleeve and interact more with others. And I think that is really what I believe, what drives me. And in some sense, Algorand is really the same, because we want this to be a platform where everybody's welcome, everybody can interact. And why? Because they are safe in doing so, right? And they are actually efficient in doing so at the same time. So that is, in some sense, sometimes it's surprising, but these things are evolution of one core idea for each one of us, right? So, and therefore they do fit together. It's not by chance.
Right. That's an awesome answer. Very exactly what I expected you to say.
Okay,
it's amazing. Well, something of that. So we have a few questions from the community. from sort of early questions we had come in yesterday. One question we have is Algo Cat asks, do you think Algorand's blockchain size is increasing very rapidly? Do you think this will make it more centralized over time because fewer validators store the entire blockchain?
It is an excellent question because in some sense, usually, when you say, I have a mice in the house, oh, don't worry, bring in the cats. Says, well, after I eat all the mouse, I have cats in the house. Bring the dogs. Who knows what happens later, right? So somehow we thought that if we solve really all these problems about decentralization, scalability, and things, more and more transaction we are going to go, and then the next bottleneck is going to say, well, if I want to be a validator, I love Algorand, but 10 years from now, to say who can download this damn chain, you tell me that it cost me nothing a microsecond to participate to the lottery and be a validator. I'd love to be a validator, but I have to in order to be a proper validator, I have to download the stuff, and that is the new bottleneck, right? So you are suffering for your own success because the scalability has created an enormous amount of data to download. So we do these things in two ways. First of all, we are in some sense, relative to balance-based, and so therefore this is a little bit, that helps. But even so, I cannot just tell you I want to be a validator. So you don't need, like in some project, in order to say whether a transaction is valid or not, I really to go from the beginning of the blockchain till now to figure out if the money was there. In Algorand, no, and in a few other blockchain also, that you can actually look, at a balance sheet. However, who is going to give you the balance sheet when you want to get on board to say, oh, here is the balance of up to block 100 million and one. So now come be a good validator. Well, how do I know the balance sheet is correct? In fact, so what we are doing actually this summer, as our blockchain we see keeps on growing, is going to develop another technology that allows you, together with a balance sheet, so to speak, to get a very compact and easy to verify mathematical proof that the balance sheet is correct. And where does this proof leverage? Because correctness is relevant to something else. It goes back all the way to the Genesis block, because the Genesis block is the only one block that is assumed to be known in any blockchain, because it is part of the very definition of the protocol. And so with the proof, somehow, when it goes to the Genesis block, you have a very compact, that is the current balance sheet. That's all you need to know. Welcome to Algorand. Inspect this proof. Don't trust me. Don't trust my cousin. Don't trust my sister. But somehow trust math. Verify your proof yourself. And we welcome your participation, whether it is now, whether it is 10 years from now, or 100 years from now, etc.
Silvio, what's the name of that core upgrade you guys are working on this summer?
Well, let's put it this way. We call it, so the technical core is a compact chain certificate. And that is a very compact certificate, but the chain is not a compact certificate by me, the trusted certifier, or by anybody who has been entrusted by the powers to certify anything, but it's the entire blockchain. So essentially you want a system in which 80%, so to speak, of the stake of the chain, speaking loosely, wants to certify a piece of data. Now, if you believe really that 80% of the stake certify something, that's what the opinion of the entire chain. What is the difficulty is that somehow to gather 80% of the chain, you may need millions of signatures, if not now, eventually to reach that part. And so then, therefore, you need some other type of math in which to say, even though you have these millions of signatures to represent 80% of the chain, so that you trust the chain, because if you want to join the chain, by definition, you trust the chain, but you don't want to trust a certifier or 2 or 3 or 4 or 5. But then you have to sieve all these millions of signatures and show up only 128. The ones I want? No, the one that some cryptographic math algorithm essentially somehow is able to prove that these are indeed a sample representation of 80% of the chain. So that is essentially is the idea, to have this compact certificate. And this can be used for a lot of things. One thing can be used is really to onboarding without trusting anybody, new validators. They can be used to secure the chain. By the way, also to make the chain quantum secure, I want to add. And they may be used also for having interoperability with other chain. Because now we're seeing that, first of all, as you said, not all chains are decentralized, unfortunately. But even if there is one or two decentralized ones, so to speak, then when they want to interact, they rely on some certifier. Anointed by whom? Oh, they posted a bond. Now I'm going to steal words from Omar's mouth to say, how large is your bond? Is it 10 million, whatever, euros, yuan, dollars? And it's not enough, because now you have these trillions of dollars in one blockchain. On the other, and who are you? Or you say, it's not one of us, it's three of us, and as long as two are honest of the three, ... right? So what do you want here to go? If you want interoperability between one chain and another, the right way to trust nobody in between, and to trust the chain themselves, and we must be able to compactly express the opinion of the entire chain. And so these compact chain certificates are going to be used, we are developing now, but they're going to have many uses in the Algorand ecosystem.
Interesting. So it sounds like you have a pretty busy year ahead. Compact certificates.
Absolutely. This is the fun.
Yeah.
This is fun.
the spirit of evolvability, built-in evolvability in action.
Correct.
We have, guys, I think we have time for one more question, which I think is actually, I'm pretty interested in your answer to this. So the question is, why is running a relay node permission? Is it because running subpar relay nodes will slow down the network? Do you think the way relay nodes in Algorand makes it very centralized and a single point of failure?
I'm not sure that if I understood my question. My question said, why is relay node permission? No, they are not permission. Everybody can join the relay node list in Algorand.
Right.
So it's right that relay nodes, because they have to facilitate the thing, they must have a very high bandwidth, so they can facilitate, and improve our speed. But the trick in Algorand is that that Algorand is secure not only against the protocol attacks, but also about network attacks. So, for instance, if you take Bitcoin, which I have the highest respect, being the first solution and all, by all means, but at the same time, it was not the solution I would endorse. They said the assumption appears to be, but falsely, that if the majority of the mining power is in honest hands, then Bitcoin is secure. That is only true if somebody is so cavalier, an adversary is so cavalier, that only attacks the money. But if you attack somehow the communication protocol, all bets are off. And in fact, you can, in Bitcoin, even if 100% of the mining power is in honest hands, you can somehow double spend with impunity. So not in Algorand. So that's why we welcome relay nodes, so that everybody can join them. That we do not rely on them for security. They can help us if they want. They can slow down if they don't really work, but they cannot subvert us. Okay, so and that is a primary reason for which, first of all, is an open list. Join if you want to become a relay node, but we do not depend. Our security does not depend on that. Only depends how fast we are, which, by the way, and that's a different story.
Right. Cool. Yeah, I think we've been running one since 2019, mid 2019. So yeah, we didn't have to get permission to do that. Cool. Well, this has been awesome. Thank you, Silvio. I mean, it's been a real honor to to be able to do this with you and
the pleasure is
dive
mine.
into the protocol.
And I must say, this is your show, it's your report. You need the congratulations for a really a novel analysis, and I really hope that people pick it up and start reasoning like you guys do on the very foundational idea of blockchain, and not just in some fringes like of fringe aspect, because we need to have a rigorous analysis and of the foundations of the field, and what does make a blockchain tick, and how do we value these core properties and so forth. So in any case, it's been a pleasure talk to you, to your audience. Thanks very much. A good day to everybody.